All right, so I decided to record because of internet problems. Here is number 44 as an example. This is part of your homework. So first I'm going to divide 125 and 5. After I do that, I am going to take care of the A's and the B's. Okay, so first we're going to do 125 divided by 5 because they're both coefficients. You're just dividing them, you get 25. Then I'm going to take care of the A's. They are both a to some kind of exponent. So it's supposed to be a to the 4 over 3 minus 2/3. So I apologize about the typo. So it's a to the 2/3. And then the B's, I did do correctly. So learn from my B's. It's b to the 5 over 6 power minus 1/2. Then here we're going to have to do common denominators, because we want both to have the same denominator, in this case the denominator is 6. If we subtract 5 over 6 and 3 over 6, you get 2 over 6, which is to the 1/3. Right, so that's how you do that one so far. Don't forget that we have an exponent of 3 over 2. So now from here, we're going to do, not forget that 25 has an exponent. It's secretly an exponent of 1. Once you have your exponents ready, don't forget that we are technically multiplying everything by 3 over 2. These are properties of exponents taken to a power. So the first term we're going to multiply is the 1, and then the second exponent 2 over 3 and 1 over 3. So we're multiplying all of them by 3 over 2. I didn't really show how to do it with scrap. I just showing you the answers here. So it becomes 25 to the 3 over 2 power, a to the first power, and b to the 1/2 power. And just so you know, the square root of 25 to the third power is the same as what I wrote before. I just converted it to radical. And the square root of 25 is the number 5. So I am going to do 5 to the third power. So we have 5 to the third power, a to the first power, and b to the 1/2 power. They said to keep it in rational exponents. Finally, your answer is 125 ab to the 1/2 power. We're going to do 53 as another example. It should help you with your test tomorrow. So I'm going to actually take care of the inside again. I'm going to do division means subtraction because they're both xx and they're both yy. So I can do properties of exponents. So for the x's, remember you're doing top minus bottom. So 2 minus 12 is negative 10. If it's negative on the top, it's going to go on the bottom. So that means that I know in my final answer, x to the 10th power should be in the denominator. So I'll set it up for you so you can see what I'm doing. X to the 10th power. Now the y value is the blue one. So I'm doing 19 minus 2, which is 17. Notice it's a positive 17, so nothing happens to it. It doesn't get flipped like the negative exponent. Now, since you have to the fourth root, don't forget that the fourth root means 1 over 4. So that's what we're going to do both with the numerator and denominator separately. We're going to try to split up 17 to be two numbers that can divide by 4. So I decided to use y to the 16th power and y to the first power. So 16 plus 1, because when you multiply, you're adding, is equal to 17, just to verify. Then we have to do the same thing for x to the 10th power. We're going to choose x to the 8th power and x to the 2nd power, because 8 plus 2 will give me the 10 when I multiply them, because multiplication means addition for the exponents. All right, so now for some of these, the answer is easy. So the ones that are easy are the ones that were divisible. So to do the fourth root of y to the 16th power, it's actually y to the fourth power because it's 16 divided by 4. And then for the fourth root of x to the 8th power, it's just going to be 8 divided by 4 in the exponent part, which is x to the 2nd power. Notice the other two are still in fourth root because we could not do anything there. Okay, now it's your favorite part of the day. We have to rationalize the denominator. So how do you know when you have to rationalize the denominator? If you have any radical in the denominator. So that's fourth root, cube root, fifth root, square root, it doesn't matter. In this case, I had the fourth root of x to the second power as my problem. That is what I have to rationalize. So I'm actually going to take this and I'm going to show you on a whole new page so you don't get confused how to rationalize just the denominator. Remember, we don't really care about the numerator at this point because we can calculate it if it's a numerator. We can't really calculate in the denominator. All right, so there is my problem from the last step of the previous page. And I am going to set up what I'm trying to do here. So everything stays the same except for the fourth root of x squared. So notice I'm writing everything but that last fourth root of x squared. I'm going to focus on that. I want to look for something if I multiply it with that I will get the fourth root of x to the fourth. So your goal is always to get the fourth root of x to the fourth, the fifth root of x to the fifth, the square root of x to the second. So you always want to make it look the same. That is our goal. That's how we're going to rationalize the denominator because they're going to cancel with each other. The fourth root and the fourth power are going to cancel. That's the whole point. So from here, we're going to do the fourth root of what? So the answer is of x squared. So the fourth root of x squared. Because if you do the fourth root of x squared times the fourth root of x squared, you get the fourth root of x to the fourth. Notice on top, I do have a new member for the numerator because I multiplied top bottom. And in the denominator, notice that it just became an x. So I'm rewriting it so you can see. Okay, there's only a couple more steps. From here, there are stuff that we can bring together. If both of those are underneath the fourth root, we can bring them together. And x squared times x is also available to put together. So it'll be y to the fourth power, and then the fourth root of y to the y times x squared, same thing as saying x squared times y. And then x squared times x is x cubed. And that is how you do those two questions. Hopefully it helps your homework.